Hello, welcome back to another LeetCode problem. Today we are doing question 11, a medium rated question. This is container with the most water. You're given an integer array height of length and there are n vertical lines drawn such that the two endpoints of the ith line are I at 0 and I at height at I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, now what does this problem really mean? Well, I pulled one of their examples, and basically all we are given is some array. In this case, it's going to be 1, 8, 6, 2, 5, 4, 8, 3, 7. And this array is called height. Now, what does this array mean? Well, these are just different heights of different pillars. And so how does this end up? What does it look like? Well, if we look at their image, this 1 corresponds to this block, this 8 corresponds to here, and notice that they have a height of 8. This has a height of 8, this has a height of 8, a 6 with a 6, and so on. Now, if I were to pick two pillars in here, which one of these would make the biggest possible container? Now, there are a few things to take into account. We can just take, we can take the two biggest ones, 8 and 8. That makes sense. Well, if we want a big container, we want it to have high walls. But there's another thing to consider. Let's say this is here. Let's say this is the container we make. But what if we can use a smaller wall, but it's further away? Now that means the width is actually larger. So even though this is shorter, this becomes a more optimal wall. Because remember, here, well, we are only worried about a 2D area. So area would end up being length times width. Okay. Now, what is length and what is width? Well, okay, instead of length, let's use height. That makes more sense in this context. Height is how tall is this container. Okay, well, notice this. If we were to use the outside two walls, so ignore this one, well, how high can the water go up? The water can only go up to here, right? Meaning that the container actually has a height equal to the shorter pillar. Okay, so that we know we have to find the minimum of the two pillars somehow. Okay, that's pretty easy. We can use a minimum operation. Now, what is the width? The width is actually this index minus this index. That gives us the difference, and that just gives us a relative width between them. We aren't really given any coordinates or any dimensions on how big the x-axis is. We're just assuming that the indexes represent like different widths. Okay, now in this case, what they did in their algorithm is they would have had to compare a lot of these, for example, a lot of these to like pairs of pillars. They invented these two, the two longest ones, and every time they calculated the width. But at the end, this one actually resulted in the biggest one, because let's do the math. Remember, let's compare this with this and this with this. Okay, so if we look at let's do the 8 times 8. So we have a minimum between 8 and 8, which is 8 times, remember the difference. Now we'll use indexes, 0, 1, 2, 3, 4, 5, 6, 7, 8. And what is the difference here? It's 6 minus 1. And this ends up being 8 times 5, which is equal to 40. Okay, that's not bad. But what if we use this 8 and this 7? Well, the operation ends up being the minimum between 8, and 7, and this does lower the total because we're going to use 7 instead of 8, but if you notice, we're going to increase it by looking at the difference. This ends up being 7 times 7, which is equal to 49. And this proves that using those two pillars, because they are spaced out, we can hold more water. Okay, so now that we understand the problem, how do we solve it? Well, there are two ways to do this, two ways that I solve this problem in. The second way that I will show you is the better way because it uses constant memory, whereas this one is dependent on the size of the array. What you would do is actually here. Let me just write out the array again. 1, 8, 6, 2, 5, 4, 8, 3, 7. What you can do is we would pre-initialize two different arrays with the numbers 0. Actually, they wouldn't even be like that. Okay, how it would work is so we would have a left array, and let's go through the left. The left, there's some variable m which stores the maximum while we are iterating through, and here we would just store the maximum that we have found so far and that maximum's index. Now move to here, and that's 8, so it would be 8 and 1. This would be 8, and we would be storing that index as well. Now we go here, it's not bigger, so we keep the 8 and 1. Go here, here, here. We're gonna do it for the entire thing. Okay. So, and this is of what length? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So let's just fill it up really quick. This is 5. This is 6. This is 7. And this is 8. And 9. Okay, now how do we use this? Well, first we are going to reset this into 0 and set this index to the max, which is what? 0, 1, 2, 3, 4, 5, 6, 7, 8. And we're going to do the same thing but with a right array, and this stores the exact same thing, but we're going from right to left. So the very first one is actually, well, this ends up being 7. So this gets stored as 7 and 8 here. 3 is not bigger, so 7 and 8. And now we are at 8, and this is index 8, 7, 6. So this becomes 6, this becomes 8. 8, and this goes on for the rest of it because 8 is the biggest number. So that's 4. It's 5, and so on. Let's just fast forward a bit. Well, what does this tell us? Well, if let's say now we were to iterate through every single value again, well, we can actually, for example, let's say we are at this 5. We're at index 0, 1, 2, 3, 4. If we go to the same indexes on the other arrays, 0, 1, 2, 3, 4, so this one, it's basically saying that to the left of the 5, the biggest container is actually 8, and it's at index 1. And if we do the exact same thing here, well, this starts 8, 7, 6, 5, 4. It'd be this one. It's saying that to its right, the biggest one is actually this 8 at index 6. And this basically, what you would do is you would iterate through every single position, take the corresponding left max and right max, and then take again the minimum between them. So in this case, it'd be minimum of 8 and 8 multiplied by the difference in indexes, which is 6 minus 1, and this ends up being 40. So this was the case with the biggest ones. And you would continue to do that whilst keeping track of this as a max. And then you would return. Now that is, yeah, that is pretty much all for this method. But pre-initializing these arrays does take a lot of memory. There is a much easier way to do it, and that's using 2 pointers. And how do we do that? Well, if we use the exact same array again, E37, we initialize the left and the right, and from here we have a total, and we calculate. Well, this ends up being the minimum between 7 and 1, and you take the difference between their indices, which is times 8 minus 0, and this ends up being equaling to 8. Now here, t is equal to 8, okay, and we store that as sum total. Here, if we move whichever one is smaller, since left is smaller, we want to move it. Okay, now we do this again, and we do 8 and 7 between 8 and 1, and this ends up being 7 times 7, which is 49, and at total, if 49 is greater than whatever is already stored, then we update it. Now between these two, right is smaller, and you can get the idea. We'll always move the one which is smaller, because that one we can get rid of easily, whereas the bigger one we do want to keep because it has more potential for a bigger container. And overall, this does give us constant space for memory, but our time complexity, well, it is very efficient still. It's O to the n, linear time. Now let's head over to LeetCode and see if we can solve this. Okay, so over in LeetCode, what do we want to do first? Well, first we want to create the variable which will store the total, and let's pre-initialize it to 0. And since we are using a 2-pointer approach, we always want to set these pointers up, which ends up being 0 for height, so it starts at the beginning, and the length of height minus 1 for right, which is at the end. Now, as long as left and right are not equal or cross each other, we want to continue on looping. And here, total, we will set it as the max between, well, it'll either be total, whatever it was before, or if maybe we can get a higher number by finding a new area, which again is the minimum between the left and the right. And let's fix this spelling. Height. Okay, multiplied by the right minus the left. So again, this formula gives us a new area, and this max operation compares that new area to whatever our maximum area onto that point is. And now we want to update our pointers. If height at left is greater than height at right, then we want to decrement the right pointer. Otherwise, we want to increment our left pointer. And at this point, once we exit the while loop, at some point we have found the maximum area. And if we didn't make any mistakes, we should be able to just check. There you go. It does pretty well. I hope you guys enjoyed the video, and I hope you can understand the explanation, and I'll see you guys in another video.